Hi, this is Alex from devstories.eu. Docker Masterclass, episode 15 of 18. An autonomous AI coding agent is exactly the kind of process you do not want running with root access on your laptop. You ask it to fix a bug, and suddenly it is downloading arbitrary packages, modifying system files, or trying to rebuild your local infrastructure. You need a place where the agent can act like an administrator without actually being one. This is what Docker Sandboxes for AI are designed to solve. Traditionally, Docker isolates processes using Linux namespaces and control groups. Those containers share the host operating system kernel. For a predictable web service, that model works perfectly, but an AI agent is inherently unpredictable. It generates unverified code, executes it, and often needs to install new system packages on the fly to test its own solutions. Sharing the host kernel with an unpredictable agent is too much of a security risk. To address this, Docker Sandboxes abandons standard container namespaces in favor of isolated microVMs. When you spin up a sandbox for an agent, it boots a dedicated lightweight virtual machine. The agent gets its own distinct kernel. It cannot see your host processes, it cannot access your host network stack by default. Most importantly, it completely eliminates the risk of traditional container escape vulnerabilities. The agent is strictly confined to a hardware virtualized box. This matters immensely when you consider what AI agents actually do. Imagine your agent is tasked with writing a complex web application, creating a Docker file for it, and testing the build. To accomplish this, the agent needs to run Docker commands. If you simply mapped your host system Docker socket into a standard container, the agent could theoretically launch privileged containers directly on your host machine. Docker Sandboxes prevent this by running a completely isolated Docker daemon inside the microVM itself. The agent can build images, pull external dependencies, and run nested containers all day long. Because it is talking to the isolated daemon inside the microVM, your host system Docker environment remains completely unaware and unpolluted. When the task finishes and the sandbox is destroyed, the internal daemon and all its downloaded images vanish immediately. This is where it gets interesting. If the microVM is completely isolated, how do you actually get the finished code back out? The architecture solves this using workspace mounting. This is a secure file system pass-through mechanism. When initializing the sandbox, you define a specific directory on your host to act as the workspace. This single directory is safely mounted into the microVM. As the agent writes code, runs tests, or generates assets, it saves them to this workspace directory. The pass-through synchronizes those specific files back to your host file system in real time. The agent delivers the requested output without ever having access to the rest of your hard drive. It can freely break things inside the microVM, but your local files remain untouched. The core insight is that isolation in this context is no longer just about protecting the host from malicious external software. It is about safely enabling the unpredictable, highly privileged system operations an autonomous agent must perform to actually be useful. If you enjoy these episodes and want to support the show, you can search for Dev Stories EU on Patreon. That is your lot for this one. Catch you next time.